Alright, for your warm-up, it says find the exact value of sine of 2x if sine of x is 2 over 3 and its terminal side is in the first quadrant. So first thing I notice is it says in the first quadrant, so I'm going to draw a triangle in the first quadrant. And so there's my triangle, it's x, and it tells me that sine is 2 over 3, so that's opposite over hypotenuse, so that's going to be 2, and that's going to be 3. Once I've got that, I'm going to go ahead and find the missing leg. That's right, so I do a squared plus 2 squared equals 3 squared, so that'll give me a squared plus 4 is equal to 9, so you get a squared is 5, so that means that this leg is radical 5. And that's really the hardest part, because now, if it wants you to find sine of 2x, the formula for that is simply 2 sine of x cosine of x. And so sine of x was given, it's 2 over 3. Cosine of x is square root of 5 over 3. And so then you just multiply straight across. 2 times 2 is 4, so you get 4 radical 5, and then 3 times 3 over 9. So you just get 4 radical 5 over 9. Pretty straightforward, right? But just making sure you draw the triangle, do Pythagorean theorem, and do all that, and then just do your formula. And again, you don't have to memorize the formula. The formula will be given to you. All right, what I want to do today is I want to review some problems that we did prior to this unit, because you're still going to have spiral review on here. So again, we're going to be reviewing, but we're going to be reviewing some of the older stuff too. So I'm going to go ahead and jump right into this. And so here's our next problem. So the essential question is, what do you know to pass this test? I'm going to go through about 10 problems with you to help you remember what we did for this unit, for the unit before. So here's your first problem. It is a lengthy one, so you don't need to write it down, but it says the distance between Miami and Orlando is about 220 miles. So I'm just going to draw you a picture so you can see this. So if you can imagine, Orlando is right here, and Miami is right here. It says the distance between Miami and Orlando is 220 miles. So that distance right there is 220. It says a pilot flying from Miami to Orlando has to start the flight 12 degrees off course. So he can't go straight because they're wanting to avoid a storm. So they start flying this way instead. And let's say that this is 12 degrees right there. What they're doing is they fly that direction for 90 miles. So this is 90 miles. So the plane is right here right now. The question is, how far is this plane from Orlando? So it wants to know what this length is right there. Well, this is a law of cosines problem. And again, you'll have this formula on the test, but the law of cosines formula looked like this. It was c squared equals a squared plus b squared minus 2ab cosine of c. And so in this problem, you're trying to find c, so you're going to take the square root of both sides to get that answer. So all we're going to do is plug in the numbers. So literally plug in 220 squared plus 90 squared minus 2 times 220 times 90 times cosine of your angle, which is 12 degrees. Now the only thing that might cause you some problems is making sure your calculator is in degrees mode. But other than that, it's literally just plugging it into the calculator. So I don't want you to miss this type of problem, because the only thing that I'm going to change on the test are the numbers. And so if you type it in exactly as you see it, you should get approximately 133.3, and that would be the answer for that. So don't make that problem any harder than it is. Just simply plug in those numbers and then just type it in the calculator. That's it. So the square root of 220 squared plus 90 squared minus 2 times 220, 90, cosine 12. That's it. That's as hard as that problem is going to get. So just remember law of cosines for that. All right, for the next problem, it says solve the following triangle with a given measurement. So here's the triangle that I have. I'm just going to draw it for you. This is A, this is B, and this is C. So it says that side B is 25, so that goes across from angle B. It says that angle B is 33 degrees, and it says that side A is 33. So I've got a 33-degree angle, and these are my two sides. Well, I'm going to put a little note right here. You have to watch out for this one, because this is a side-side angle situation, so that is the ambiguous case. It's been a while since we've done one, but it's the ambiguous case, which means there might be a second triangle, and we're going to test for that in a minute. But right now, let's just worry about the first triangle. So to do this, I'm going to have to use law of sines. I have no choice. I have to find angle A first, since that's the only side I've given. So if I set this up, I'm going to have 25 over sine of 33 equals 33 over sine of A. So 33 over sine of A. And then what I'm going to have now is I'm going to just go ahead and solve this for A. So I'm going to cross multiply. That'll give me 25 sine of A equals 33 sine of 33. And then to solve for A, I'm going to divide both sides by 25. And just remember, because you're having to find an angle, you've got to do sine inverse. So that'll be sine inverse of 33 sine of 33 over 25. So it's been a while since we've done one of these, so I'm going to type it in. So I'm just going to type in sine inverse, and then I'm going to make control divide, so 33 sine of 33 over 25, and that gives me 45. I'm going to round that up to 46. So this is 46 degrees. So this angle right here is 46 degrees. Now, what I'm going to do is I'm going to go ahead and test to see if there's a second triangle. And the way you do that is you take the angle you just got and subtract it from 180. So 180 minus 46, that gives me 134 degrees. And then to test it, you add the given angle, which in this problem was 33. And if you add that together, you get 167. If that's less than 180, you've got a second triangle. So I do have a second triangle, and I'm going to label it A, B, C. The only difference is, in the second triangle in blue, angle A is not 46 degrees, angle A is 134 degrees. But everything else remains the same. This is still 33, this is still 25, and this is still 33 degrees right there. So now I've got to solve both of these triangles. So I'm going to go back to the red triangle. Since this is 33 and this is 46 degrees, if I add those together and subtract it from 180, that'll give me 101 degrees, so that's the angle right there. And then I can solve for side C by doing the law of sines again. I'll do C over sine of 101 equals 25 over sine of 33. And then I'm going to get 25 sine of 101 equals C sine of 33. And so now just divide by sine of 33 on both sides, and that'll give me C. So I'm going to have 25 sine of 101 and divide that by sine of 33, and that gives me 45. And so that would be this measure right there. And so that's my, let me go back and write it again, 45. So that is that triangle right there. And so now I can finish solving the blue one also. I'm going to add up 134 degrees plus 33 degrees, subtract that from 180. That gives me an angle of 13 degrees, so that's 13 degrees right there. And then do the same thing. I'm going to put it up here. C over sine of 13 degrees equals 25 over sine of 33 degrees. Cross multiply, so you get 25 sine of 13 equals C times sine of 33, and then just divide by sine of 33. So you're going to have 25 sine of 13 divided by sine of 33, and that gives me 10.3. So this measure is 10.3. And so that's it. My blue triangle and my red triangle, that will be my answer for that problem. So, and I will tell you this, on the test, it's going to be an ambiguous case. I'm not going to lie. It's going to be a problem that's like this, so you can rest assured you're going to get two triangles. And so that will be it for that problem. All right, another review problem we had was if I ask you to find the area. Now, don't worry. You're going to be given the formulas on the test. So if it asks you to find the area, just find the area formula that works. I'm going to go ahead and draw the scenario so you can see it. This is triangle A, B, C. And so angle B is 132 degrees, angle A is 18 degrees, and side C is 8.9. If you remember, this is when you have two sides, two angles on a side. This is angle, side, angle. And so when you have this, the formula for that is 1/2 A squared sine of B sine of C over sine of A. So in other words, you have to know all three angles. Well, you can find that missing angle really quickly, because all you got to do is just add 132. So I'm going to add 132 degrees plus 18 degrees and subtract that from 180. That gives me this angle is 30 degrees. Now, the only thing that I remember people missing on it is writing this out in the formula. Remember, this represents my side. Well, the only side I give you is 8.9. So I'm going to have 1/2 times 8.9 squared. But this is what's crucial. Whatever side I give you, its angle goes in the denominator. So notice that 8.9, its angle is 30. So you're going to put sine of 30 in the bottom. So yes, it does matter which angle goes where. You have to put that angle that its side goes with. You need to put that one in the bottom. But that's it. So you're going to type this into the calculator. So I'm going to just type in 1/2, make a fraction, 1/2 times 8.9 squared times, control divide, sine of 132 times sine of 18, and in the bottom, sine of 30. And if you type that in, you should get an area of 18.2. And that's it, just typing that in. Make sure you hit a time symbol and a time symbol right there, but you ought to be able to type that into the calculator and get it fairly easy, really quickly. That's all that you got to do for that problem right there. Just find the area. Make sure you use that formula, though. That formula is the one that's key, and make sure you put the angle in the right place. All right, the next type of review problem is solving an equation. It's been a while since we've done one. It says solve the equation for x between 0 and 360. Remember, you will get two answers for this. It says sine of x is equal to the square root of 3 over 2. Remember, A Smart Trig class, so it's asking you where is sine positive. So look at your A Smart Trig class. So the two places where sine is positive is in quadrants 1 and 4, right? So that's where my two answers are going to be. So to solve this for x, did I say 2 and 4? 1 and 2. And so then to solve this for x, all we're going to do is do the inverse. So type in your calculator, sine inverse of radical 3 over 2. Just type that in exactly as you see it. So sine inverse of radical 3 over 2, and then that should give you 60. And so that's one of my answers right there. So 60 degrees is in the first quadrant. It's right here. The question, though, is how do I get my second answer? Well, whatever your reference angle is, draw it over there in the other quadrant, and then just do this. Yep, subtract from 180. So 180 minus 60, that gives me my second answer of 120 degrees. So those will be my two answers for that, 60 degrees and 120 degrees. So those will be my two answers for that problem. And that's it. That's all that you've got to do for it. All right, for the next type of problem, it says find the exact value. It's been a while since we've done one of these. This is on the first test. To find the exact value, the first thing I'm going to do is convert this from radians into degrees. So I'm going to multiply this by 180 over pi. The pi's are crossed out, and so that'll give me secant of 11 times 180 divided by 3. That gives me 660. And then I need to find a coterminal angle, so I'm going to subtract 360 from that. That gives me secant of 300 degrees. And so now I can actually find out where this is. 300 degrees is in quadrant 4, and it has a 60-degree reference angle. And so then I can label this radical 3 over 2 and 1/2. But be on the lookout. You've got to watch out for your signs. That's a negative, and that's hypotenuse of 1. And then do your trig ratio. Secant is the reciprocal of cosine, so that's going to be hypotenuse over adjacent. And so that'll be 1 over 1/2, and then stay, change, flip. So 1 times 2, so that gives me an answer of 2 for that problem. Just make sure you stay, change, flip, or keep, change, flip, however you want to look at it. But that would be the answer for that problem. Just making sure that you do your trig ratios right. That's it. All right, for the next type of problem, it's another review. It says, given the point -8, -5, it lies on the terminal side of angle x, find the value of cosecant. Well, the first thing I'm going to do is I'm going to plot this point. So -8, so 1, 2, 3, 4, 5, 6, 7, 8. -5, 1, 2, 3, 4, 5. So there's -5. So there's that point. So if you can imagine an angle there's my angle right there. There's my value for theta. There's my right angle. So I can do Pythagorean's theorem on this now to find my hypotenuse. So I'd have negative 8 squared plus negative 5 squared equals c squared. So I have 64 plus 25. If I add that together, I'm going to get 89. So that means the hypotenuse is the square root of 89. And then to find cosecant, cosecant is hypotenuse over opposite. So that would be square root of 89 over negative 5. And that will be my answer for that problem. So just remembering Pythagorean's theorem, that's crucial. Hypotenuse is radical 89 and opposite is negative 5. So that will be my answer for this type of problem, just radical 89 over negative 5. All right, for the next one, this is actually stuff that we learned for this unit. If I wanted to simplify this, if you remember, tangent of x is, by definition, sine of x over cosine of x. I'm going to leave cosine squared alone, so that's going to be cosine squared of x. But secant of x I can rewrite as 1 over cosine of x. And so I'm going to rewrite this a little bit better so you can see it. So I'm going to have sine of x over cosine of x, and then cosine squared is cosine x times cosine of x, because a very interesting thing happens. All the cosine of x's cross out, and the only thing that's left behind is sine of x. And so my answer for this problem would be sine of x, and that would be it for that problem. All right, so that's just sine of x. All right, for the next one, it wants you to verify. Remember, verify was when you picked a side and you tried to make the one side look like the other. So I'm just going to draw a line straight down. So I want this side to look like secant. So here's what I'm going to do. I'm going to rewrite tangent as sine over cosine. I'm going to rewrite cosecant as 1 over sine. The sines cross out, and so if I multiply, I get 1 over cosine, and we know that 1 over cosine is the same thing as secant, and that is what I wanted to begin with. So I verified that secant of x is equal to secant of x, and that would be the answer. It's not really an answer, but you just had to show that those two things were equal, and that's what you did for that problem. You verified it. All right, for the next type of problem, it says that if cosine of x is 5 over 12 and sine of y is 4 over 5, and x and y are both measures of angles in the first quadrant, find sine of x plus y. Well, I'm going to write down the formula for you. You don't have to memorize it, but the formula for sine of x plus y is sine of x cosine of y plus cosine of x sine of y. Well, I already tell you that cosine of x is 5 over 12, so we know that this is 5 over 12. I also tell you that sine of y is 4 over 5. So I know that this right here is 4 over 5. So that is 4 over 5. What I don't know is, I don't know what sine of x or cosine of x is. So this is where I'm going to have to draw my triangles for both of them in the first quadrant to figure out what those are. So I'm going to draw a triangle in the first quadrant, angle x, and it says cosine is 5 over 12, so that's adjacent over hypotenuse. You could do Pythagorean's theorem, but I'll go ahead and let you know that if you did Pythagorean's theorem on that, you would get the square root of 119, 5 over 12, so that's 144 minus 25. So you get the square root of 119 for that missing leg. And so then now you can figure out what sine of x is. Sine of x then would be radical 119 over hypotenuse of 12. So that would be radical 119 over 12. And then cosine of y, so draw one for cosine. So here's my y triangle. It says sine of y is 4 over 5, so this is 4, this is 5. And y'all know that this is a 3, 4, 5 triangle. So there's my triangle. And then from that I can say that cosine of y is 3 over 5, and so that goes right there. And so now let's just clean this up. So radical 119 times 3 would be 3 radical 119 over 12 times 5 is 60, plus 5 times 4 is 20, over 12 times 5 is 60. They have the same denominator, so I can scrunch these together and get 3 radical 119 plus 20 all over 60. And that would be the answer for that problem right there. So you do have to draw the triangles, do Pythagorean theorem, do everything that we've been doing this whole time, but just making it all together at one problem. That would be the answer for that one. All right, for the next one, it wants to verify sine of 90 minus x. It wants to verify that that's equal to cosine of x. So we're going to use my sum and difference. So this is going to work out to be sine of 90 cosine of x minus cosine of 90 sine of x. And I want to verify that's equal to cosine of x. Well, if you plug in sine of 90 in your calculator, it will give you 1. If you plug in cosine of 90 in your calculator, it'll give you 0. And so then 1 times cosine of x is cosine of x. 0 times cosine is 0. And so cosine of x minus 0 is cosine of x. And that was what I wanted to verify to begin with. So cosine of x is equal to cosine of x. So I verified that that is true and valid. So that works. That's perfect. All right, for the next type of problem, I've got express cosine of 240 as a function of an angle in quadrant 1. This was a two-step process to do this. The first thing you do is find the reference angle. So 240 is in quadrant 3. The reference angle to 240 would be 60 degrees. So I know that my answer would be cosine of 60. But then the question is my answer positive or negative? Do a smart trig class. In quadrant 3, only tangent is positive, which means my answer needs to be negative. So my answer would be negative cosine of 60 degrees. And we had a quiz on that before we had fall break, and that was one of the problems like that was on it. So that's the answer to that one, negative cosine of 60 degrees. And that would be the answer for that problem. All right, for the next one, it wants you to simplify cotangent squared minus cosecant squared. Well, I remember that cotangent squared is cosine over sine, and I also remember that cosecant is 1 over sine, so that's 1 over sine squared. They have the same denominator, so I can combine them together and get cosine squared of x minus 1 over sine squared of x. And then this one, in the numerator, is a Pythagorean identity. If I remember correctly, cosine squared plus sine squared is equal to 1. So if I shuffle this around, if I move this sine squared over here and move this 1 over to the left, I'd get cosine squared of x minus 1 equals negative sine squared of x. So that means that this right here is negative sine squared. So I'd have negative sine squared over sine squared. The sine squareds cross out, and that doesn't leave 0. That leaves behind a negative 1. And so that would be the answer for that problem. It would just leave behind a negative 1. And that would be the answer for that type of problem as well. All right, for the next one, it has a similar one that we just did. It says express tangent of negative 145 as a function of an angle in quadrant 1. The first thing I got to do is I need to know where this negative 145 is. So I'm going to add 360 to get my coterminal angle. So negative 145 plus 360, that gives me 215. And 215 degrees is in quadrant 3 again. So then to find the reference angle, do 215 minus 180, and that gives me a reference angle of 35 degrees. And so I know that my answer is going to be tangent 35. But the question is it positive or negative? We'll do a smart trig class. In quadrant 3, tangent's positive, so I know that my answer would have to be positive tangent of 35 degrees. And that will be my answer for that problem right there for number 15. All right, for the next one, it would have to look like this. It says use the sum or difference identities to find the exact value of sine of 375. And so for 375, you'd have to split this up into 2 angles. So I know 45 is going to be one of them. So 45 is one of those angles. And I want to add to get 375, so I'm going to use 330. So that's going to be my other angle right there. And this is for sine, so that would give me sine of 45, and then cosine of 330, and so then plus, and then that would be cosine of 45, and then sine of 330. And so my pen had died, so I'm having to write this with the mouse. So then that would be that right there. And so then we know that with a 45-degree angle that my sides are the same. So I know that this 45 that's right here, both of those are going to be radical 2 over 2. So I know that this one and this one are both going to be radical 2 over 2. And so this one is also going to be radical 2 over 2. But for 330, I don't know exactly what that is. So 330 is in quadrant 4. It has a reference angle of 30 degrees. So then across from 30 is 1/2. So this over here is going to be 1/2. And then that means the other one is going to be radical 3 over 2. And so then we're just going to multiply this out. And that's going to give me radical 6 plus radical 2 over 4. And that would be the answer for that. Wasn't able to write as much as I wanted to because my pen died, so I wasn't able to copy it all the way down. But that would be your answer, just radical 6 plus radical 2 over 4. And we've done a lot of those. All right. For the next one, it wants you to find tangent of x plus y. And so for this one, the formula for tangent of x plus y is just tangent of x plus tangent of y, and it's over 1 minus tangent of x times tangent of y. And so notice that I tell you a couple of things. First, I tell you that tangent of x is 4 over 3. So that means I'm going to have 4 over 3 plus, and then I also tell you that cotangent of y is 5 over 12, which means tangent of y would have to be 12 over 5. And so then that's what I'd get up there. And then in the bottom, I'd have 1 minus 4/3 times 12 over 5. And so then what I'm going to do is I'm going to use my calculator to help me get that answer. So I'm going to open up the graphing calculator that's right there. And then I'm going to put that in the graphing calculator. So I'm going to put in 4 over 3 and 12 over 5. So I'm going to hit Control Divide and then Control Divide again. 4 over 3 plus Control Divide 12 over 5, and then 1 minus Control Divide 4 over 3 times 12 over 5, and that gives me negative 56 over 33. And so that would be my answer for that problem. It's negative 56 over 43. And let me go back to it. So it's negative 56 over 33. Negative 56 over 33. So this problem would be negative 56 over 33. And that would be the answer for that problem. All right. Now, for the last one, it has been a while since we did graphs, so it says state the amplitude, period, phase shift, vertical shift, max and min for the following trig function. I'm going to start off with the amplitude. The amplitude is always the absolute value of that Lie coefficient. So the amplitude for this problem would be 4. The next one, the vertical shift. The vertical shift is always that last number on the outside, so the vertical shift for this problem would be 2. And now that I know my vertical shift in the amp, I can find the max. The max is going to be your amplitude, your vertical shift plus your amplitude, so that's going to be 2 plus 4, so that's going to be 6. My minimum My minimum is your vertical shift minus your amplitude. So 2 minus 4, so that's going to give me -2. So that will be my max and my min. And then to find the period, the formula for period is 2 pi over k. And if you notice in this case, k is just 1. It's an understood 1. I'll show it to you right here. There's my understood 1 that's right there. And so my period would just be 2 pi. And then finally, for the phase shift, the formula for phase shift is -c over k. So I'm going to have to put it in here in black. So for my phase shift, that is -c over k. And so in this problem, my value for c is pi. So I'd have -pi over 1, which means my phase shift would be -pi. And that would be the answer for that one as well. And so that covers everything for review for right now.